Welcome to the DIY Honda Garage channel. This presentation focuses on the diagnostic trouble codes, DTCs, P0351, P0352, P0353, and P0354 for the Honda Accord models from 2017 to 2023. Each of these codes corresponds to a malfunction in the ignition coil circuit associated with a specific cylinder. The ignition coil plays an essential role in converting the battery's low voltage to the higher voltage needed to create a spark in the engine cylinders. The Engine Control Unit, ECU, monitors and controls the ignition coils to ensure efficient engine performance. Located on the engine, the ignition coil generates the necessary voltage for the spark plug. This failure can lead to engine misfires, poor fuel economy, and overall engine performance issues. Understanding the components affected by these DTCs is crucial for effective diagnosis and repair. The DTCs P0351, P0352, P0353, and P0354 refer to ignition coil circuit malfunctions for cylinders 1 through 4, respectively. An ignition coil transforms the vehicle's low battery voltage into a high voltage necessary for generating a spark at the spark plug. Each cylinder relies on its own ignition coil to initiate the combustion process. Located on the cylinder head, the coils are mounted near each spark plug. A malfunction in any of these components could disrupt the ignition process, leading to misfires. These circuits are powered by the Engine Control Unit, ECU, which adjusts the timing and sequence of sparks needed for optimal engine performance. Proper identification of these components is critical because a fault in one can lead to issues with all 4 cylinders if not diagnosed and repaired. The potential causes for DTCs P0351 through P0354 include several factors that may interfere with the ignition coil circuits. A defective ignition coil is the most common culprit for causing a malfunction in the circuit. Additionally, a blown fuse can disrupt the electrical flow to the ignition coils, which is critical for their operation. Faulty relay circuit boards, which manage the power supply to the ignition coils, may also lead to these trouble codes. Furthermore, wiring issues such as open or shorted wires can contribute to improper voltage delivery to the coils. Identifying these possible causes is essential for effective troubleshooting and ensures that the repair addresses the root of the problem. The symptoms associated with DTCs P0351 to P0354 typically manifest as engine misfires, which occur when an ignition coil fails to fire correctly. This can lead to reduced engine performance, notably during acceleration and when idling, making operation of the vehicle less efficient. Drivers may also notice that the check engine light is illuminated on the dashboard. Additionally, poor fuel economy is a possible indicator, as the engine struggles to operate optimally without proper ignition. Being alert to these symptoms is key to early detection and enables mechanics to proceed promptly with diagnostic measures. The first troubleshooting step involves confirming the presence of the DTCs. Begin by turning the vehicle's ignition to the on position without starting the engine. Once the ignition is in the correct position, utilize the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. This action allows you to commence fresh diagnostics without the interference of previous codes. After clearing the codes, start the engine and closely monitor for any pending or confirmed DTCs. If P0351, P0352, P0353, and/or P0354 are indicated, further investigation is warranted. If no DTCs are indicated and the system appears functional, consider checking for intermittent issues, such as poor connections or loose terminals. For the second step, begin by turning the vehicle's ignition off to ensure safety while working with electrical components. Next, swap the ignition coil from the affected cylinder with one from another cylinder. This step is crucial in isolating the issue. If moving the coil causes a DTC to appear for the previously healthy cylinder, it indicates that the ignition coil is defective. Once the coils are exchanged, restart the engine to observe if the DTCs persist. If the DTC is now showing for the moved coil, it confirms that the original coil is faulty and needs replacement. If no DTCs appear, move on to the next testing phase. In Step 3, ensure the vehicle is turned off for safety. Focus on checking fuse number A18, which supplies power to the ignition coils. With the ignition off, inspect the fuse for any signs of damage or burnout. A blown fuse can prevent the ignition coils from receiving necessary power, leading to the diagnosis of misfires or ignition failures. If the fuse appears intact, progress to the next step. However, if the fuse is blown, be sure to check for shorts in the +BIG coil wire that runs between the number A18 fuse and the relay circuit board. Repair any detected issues and replace the fuse to restore proper function. During Step 4, you will need to remove the relay circuit board for testing. The relay circuit board plays a vital role by controlling the electrical flow to the ignition coils, and any malfunction can disrupt ignition. Once removed, you should conduct tests to determine the functionality of the relay. If the relay circuit board is verified as operational, it can be ruled out as the source of the DTCs. However, if it is not functioning correctly, replacement is necessary to resolve the ignition circuit issues. Continue through the steps to ensure that any underlying problems are properly diagnosed and addressed. In Step 5, turn off the vehicle again and prepare to measure the voltage between specified test points. With the relay circuit board removed, check the voltage between test point 1, located at the relay circuit board connector C22P, and test point 2, which is grounded to the vehicle's body. This test is critical to determine if there is battery voltage present in the +BIG coil line leading to the ignition coils. Proceed to the next troubleshooting step. However, if no voltage is observed, this implies there is likely an open circuit in the +BIG coil wire that demands further investigation and repair. Step 6 begins after reinstalling the relay circuit board, where ignition coil testing resumes. First, disconnect the ignition coil 3P connector associated with the problem cylinder. With the vehicle turned to the on mode, measure the voltage between the two specified test points again. One test point is at the ignition coil 3P connector, female terminal, number 1, while the second is to body ground. This step verifies if the ignition coil is receiving adequate voltage from the relay circuit. If battery voltage is confirmed, this indicates a problem exists downstream. If no voltage is present, repair an open circuit in the IG coil RAL, IG1 coil, IG1 IGN wire, which runs between the ignition coil and the relay circuit board. Next, in Step 7, turn the vehicle off again to perform continuity checks. Check for continuity between the test points outlined previously, specifically examining the ignition coil 3P connector, number 2 terminal, and body ground. This test is crucial because it confirms whether the circuit can complete its path back to ground. If continuity exists, proceed to the next step confidently, as this indicates a proper connection. If no continuity is observed, however, it signals an open circuit in the PG coil wire running between the ignition coil and the ground G101. Repair the open circuit accordingly to ensure the ignition system can operate effectively. Step 8 begins with jumping the SCS line using the Honda Diagnostic System HDS and allowing a wait of over 1 minute to ensure accurate results. After this manipulation, disconnect the PCM connector E80P, which manages various engine components, including the ignition coils. Now, check for continuity between body ground and the specified terminal of the PCM that aligns with the problematic ignition coil. This step is crucial in identifying any short circuits within the ignition wiring. If continuity is found, repairs should focus on the IGN wire connecting the PCM and the specific ignition coil. If not, you can continue to the following troubleshooting steps. In the final troubleshooting step, check for continuity between the appropriate ignition coil 3P connector terminal number 3 and the corresponding terminal on the PCM. Pay attention to ensure the vehicle is in the off, lock mode during this test. This continuity signifies that the IGN wires are intact and functioning correctly. Should continuity be present, investigate any additional service information relating to the symptoms or existing trouble codes. Alternatively, if continuity is absent, it indicates an open in the IGN wire connecting the PCM to the ignition coil and will require repair to restore proper ignition functionality. After completing repairs, a rigorous verification process is needed to ensure everything functions correctly. Begin by thoroughly examining all connections and repairs made throughout the troubleshooting process to confirm they are secure and intact. After verifying the connections, use the Honda Diagnostic System HDS to clear any DTCs that may have remained after the repairs. Following this, conduct a road test to assess vehicle performance under normal driving conditions. Monitor for any recurrence of DTCs or symptoms that could indicate unresolved issues. Successful completion of these steps will confirm that the repairs have effectively addressed the underlying problem. Practicing preventive maintenance is crucial to reduce the occurrence of ignition system failures, represented by DTCs P0351 to P0354. Regular inspections of the ignition system and components should be conducted to identify signs of wear or failure early. Pay close attention to wiring conditions to ensure that there are no frayed or damaged wires, as these can lead to shorts or open circuits. Additionally, older ignition coils or other components should be replaced proactively, even if they show no immediate signs of failure. Implementing these maintenance steps can significantly increase the reliability of the ignition system and improve the overall performance of the Honda Accord. In conclusion, this presentation detailed DTCs P0351 through P0354, which represent ignition coil circuit malfunctions in Honda Accords from 2017 to 2023. A systematic troubleshooting approach allows for precise diagnosis and effective repair of these circuits. From verifying DTCs and inspecting ignition components to complex continuity tests, each step offers fundamental insights for mechanics handling these issues. Preventive maintenance strategies can help prolong the life of ignition systems by identifying potential failures before they lead to larger problems. Overall, understanding these trouble codes and their implications is vital for maintaining optimal vehicle performance. Please like and subscribe to the channel. See you next time.